So, if anybody's listening to this recording, my apologies, we didn't record until now. So, alright, let's get back to what we were doing. So, you guys, I asked you what x to the 5th, y to the 10th, all under the 5th root is. And it is x, y squared. Alright, moving on. We're good with that? Alright, let's practice some more. Let's go around the world. And so this is what we were talking about in the other class, that we can actually do around the world next time, where you actually get up and try and go for speed. All right, let's start here. I used to do it in elementary school. It's like one of my favorite things. Okay, get your whiteboards out. I want to see these. Do them as fast as you can. 3 to 5th. Thanks, Taylor. Taylor, thank you. Awesome. Okay, so this would be 3. Ready for another one? See how fast you can do it. But it's really not about speed, right? We're just having fun. Okay. I really don't care how fast you are, but we're going to totally play it like it's going to be fast. Just because it's more fun on stuff like this. Yeah? Okay. Don't call it out. Not 2 to the 5th, just 2. You have it? There's this is my second box this week. It's like that's okay. So this is 2. Ready for the next one? Don't call it out. As soon as you call it out, everybody's brain shuts down. Yes. Listen to Melody. She wants to learn. Okay, good. Why isn't it I? Because it's to the 5th. If it was to the 4th, then it would be I. If it was to the 2nd, then it would be I. Right?
I had no idea that.
Two. Because 8 times 8 is 64. All right. Are we starting to have some fluency in this? Because -4 times -4 is positive 16, and 16 times -4 is negative 64. We're thinking squares, right? This is how I remember that. 12 squared is 144. 13 squared is 169. And 14 squared is that transposed. Switched. The 9 and the 6. Thank you. Amadeus totally put you in check. He said we've been learning about that all week. Transposed, remember switching X and Y? Switching 9 and 6? Okay. All right. Okay, so here's where my conceptual piece comes in. So if the area of a square is 9 and the volume of a cube is 27, area being length times width, and volume being length times width times height, what is the side of the square? Because the root of 9 is 3, right? That's how you get a square. 3 times 3 is 9. So what is the root of the cube? 3 by 3 by 3, correct? Everybody with me? Okay. What about if I just said it was x squared? What would the root of that be? X by x, and the cubed. Everybody with me so far? X times x times x makes the volume of a cube, which is x cubed. Are we good? One step more. The root of x, you guys have been listening to me say it, right? What's the root of 9? What's the cubed root of 27? 3. So what's the root of x squared? X. So what's the root of x? The square root of x. This is why. Jonathan. This is why. Because the square root of x times the square root of x is x squared, and they cancel each other out. So what's the root of the cube? There's way too much talking going on back there. I'll let you guys talk in a second. So the root of x of a cube is the cubed root. Thank you. Right? No? Do you understand this? The square root times the square root equals x squared equals x? I'm just going in reverse. Okay, more? One more step? So I wrote it for you here. It can also be written like this. Because x to a half times x to a half, if I add the halves together, right? Because when I do this, isn't this x squared? X times x is x squared. What about x squared times x squared? X to the fourth. When I add the two halves together, I get a whole. It is x divided by 2. X, yeah, that's what I just said. Okay? Alright, so let's use this. Before I do that, I'd like to do this. Let's use this. So, what I'm saying is, the square root of x can also be written as a rational exponent. They mean the same thing. We're going to use them interchangeably today. And the cubed root of x can be written as x to a third. Okay? Alright, this is the next exercise I'd like you to do. Can you guys put this in 4 different categories on your desk? Put them in 4 different categories. Okay, so let's defend our thinking. Can you tell me what categories you think? Taylor, you want to give me the first 2? What? A and G. Okay, so what we're going to do with this is we're going to put them together in groups first, and then we're going to talk about them. What else? What do you think? D and F, I would agree. What else? Jonathan? B and H, would you guys agree? They have the things. And then what else? Obviously. C and E. Okay, here's the reason for this. I want to come up with rules. Because this is what happens. I taught this in 7th grade, taught it in 8th grade. I taught it freshman year. I taught it in Algebra 1. I had a couple students before, I think I told you guys this, that went with me all along. Does that make sense? I was Upland Junior and I taught 7th grade. And then the next year I taught 8th grade, and so I had some students that I still had in 8th grade. Yes.
How long were you at?
2 years.
What was your...
It was 6 years ago. So I taught Algebra 1, I taught 7th grade, then 8th grade, then I came to the high school, they followed me to the high school, and I taught algebra, right? And then I taught geometry their sophomore year, and then I taught Algebra 2 their junior, like I had them, yeah, I did. I had one. She graduated 2 years ago, or I had her every year. By the time it got to her junior year, her mom was like, at the office, like, get my daughter in her class. So, anyways, so, I mean, in fact, we knew each other so well that we ended up being, like, her mom and her went to Tahoe with me. Like, I knew that family very well, obviously. Okay, so, when you teach it each year and the kids still don't get it, there's something wrong. Correct? So my thinking is, I've been teaching this because I've been telling you the rules. You guys tell me the rules.
Okay,
No, these rules. Okay, so what's this rule? Let's come up with a rule. Okay, let's hear it, Christian.
So you read the square roots by themselves, so you add the numeral that goes before so it's like
Okay.
+1, 2,
Amadeus, you want to add to that? You, Caitlin, exponent. I like that. Let's add the two together. So if it's the same exponent, then we combine, but they're not, these are like terms, you're right. So if it's the same exponent, we combine, or I want to say combine because you're not always adding, sometimes you're subtracting, right? Combine the coefficients? Okay. You guys, this is in place of this. Because what happens, I know what happens because I grade papers. Coefficient. Why am I having such a hard time right now? Coefficient. 9 times out of 10 students mix these two up. So we're going to figure it out. So what's happening here? Taylor, you multiply the exponents. How could I like that one. An exponent of an exponent? I like it. You guys like that? You multiply when it's an exponent to an exponent? We usually call that a power to a power, but I think you guys would get it more if it was exponent to an exponent, huh? Because you don't normally call them powers. Yeah? Okay, so when I have an exponent to an exponent, we multiply. This, if you ever forget this, you just have to expand it, which leads us to the next rule. If I were to expand this, I have x to the 4th 2 times, which is 8 of them. Right? Okay, let's go to this one. You guys are kind of driving me nuts a little bit right now. Yes, please. Thank you, Melody. All right, what about this one? Could we say we can expand them or add them? Because really what you're doing here is you're writing 6 of them and 2 of them, which is a total of 8. So can we, Robert?
I was going to say, like, you add the exponents and combine them, multiply coefficients.
But these aren't coefficients.
But they have coefficients of 1.
They do have coefficients of 1. Yes. Combine what? We need to come up with a better one for this one. I don't know how else to say it right now. Expand means add exponents. Can we come back if you guys can come up with a better one? What? But this is multiplying too. Do you see what I mean? Like, I'm trying to make it so you guys don't get these 2 things mixed up anymore. But we could have multiple things in here.
What about
same base. Jonathan? It's as simple as that, right? I mean, when there's parentheses, we could put that somewhere in this definition, because I plan on writing this definition out and putting it in your notebooks for you. You know how I remember it, but it's not a definition? When I've got something like this, I only have room for a dot. And then when I have enough room, I put a plus. Not as easily. You wouldn't mix them up if you know what I mean? Okay, guys, this is the last one that I really want you to remember. What's the whole deal with this one here? I'm hearing subtract, but I want you to know why. When you expand this out, it's removing. Right? Don't I remove, when I expand this out, don't I remove 3 from the top and bottom? Expand it out and cancel it out. Thank you. Expand and cancel? Expand, because that's the key right there, is that whole expansion piece, because that's what you're doing. You're just coming up with shortcuts for expanding. So expand and cancel. All right, I'm losing you. So we have rules. This was in place of doing something like that, which you guys don't get. Right? That's what we just did. Wasn't it better the way we did it? To make you remember than this, which you guys look at and go, what? These are exponent rules. This is what people never remember. All right, this is the one I need to show you, though, because this is the one I didn't show you on the... All this is saying is that if I have an x, and it's squared, right? But I have 3 of them, then I really have 1, 2, and 3 of them. Or I have 3 out of 2. It means the same thing. So I have 3 of them, and my root is 2 into 2 parts. 3 into 2 parts, right? Because that's what this is. It's putting into 2 parts. Okay. So so using that rule, what am I going to break 16 into? Why would I put it into a 2? Because over here, I have 2 to the 4th is 16, and this is talking about 4 parts, right? So I'm going to break it into 4 parts, right? So now I have this. This, I have a number, and I'm raising it to the 3/4 power, correct? The number I have in there is really, you guys, I need the talking to stop because this is going to be key right here. Okay? So right here I have a number that is to the 3/4. Does everybody agree that there's a number here that's to the 3/4, there's a number under here that's to the 3/4? Okay. So now I'm going to talk about the fact that I have 16 is really 2 to the 4th. Correct? All right. So now I'm going to put them both together. So I have 2 to the 4th 3/4 times. So that's 2 to the 4/1 times 3/4, and the 4's cancel. And I'm left with 2 cubed, which is 8. Do we see it? This, under here, they're color-coded. So 2 to the 4th, 2 to the 4th, then 2 to the 4th times 3/4, then 2 cubed, which is 8. Okay. How are we doing? All right. Get your whiteboards out. Can you write this out for me? Whiteboards. Put it as a fractional exponent. Okay, I'll do the first. This is B. This is, whenever there's no number there, it's automatically 2. So this is B, 5 of them out of 2. What about this one?
5/3. Sorry.
Almost. Close. Taylor, close. 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 No. Okay, you're all making the same mistake. This is 5R to the 5/3. Some of you had just 5R to the 5/3, which would imply that only the R was to the 5/3, when they both are. Next. I like this one. Yes. Why isn't there a screw to... I'm turning it from a square root into a fractional exponent. They both mean the same thing. It goes away.
Is this right?
Okay.
I'll mark it dead.
Yeah, you guys got this. Okay. All right. So this one is 6x to the 1/3. All right, let's go backwards. Let's go backwards. Yeah, we're good. Yep, you guys got this. It's on your table? Okay. I think the last class liked this so much because they felt so successful. I have 5 of them out of 4. The 5 can go here or the 5 can go here. It doesn't really matter. They're both the same thing. What about this one? Looks good. I have 10 and I have 1 of them out of 6. Last one? What's that one? Yep. You guys got it. So I have m squared to the 5th root. All right, ready? Moving on? Okay. Don't shout these out. Put them on your whiteboard. What's 32 to the 1/5? Don't think of rules. Think of roots. Okay, wait. Simplify. Don't put it in the square root. Simplify. Like this one is 2. Right? Well, I know that the base of 32 is 2, right? Because 2 to the 5th is 32. See why those are going to come in handy now? See, and this is the reason why. Because 2 to the 5th is 32, and when you take it to the 1/5, they cancel out. Ready for another one? Yep. 5. Clicking now. Ready? 4. 4 cubed is 64. Ooh. Yep. All right. So 4 plus 7 is 11. About that one. Oh, they're two different problems? Because you're not trying to confuse me or anything. Good. Okay. All right, so this is 5 plus 2, right, equals 7. Another one?
Yeah.
So this one is 216. 36 to the 1/2 is 6, and 6 cubed is 216. Matthew.
I'm just enjoying you.
Right?
Yeah.
What's going on today? I can't tell. You have too many. Too many answers.
You just did a constant. Box answers.
Okay, so 4, the square root of 4 is 2, 2 to the 5th is 32. Right? You got it? You guys ready to do around the world when we get back? Good. Yep. You guys are getting this better than any of the classes did last year, and I wonder why. I wonder what I did differently. Huh? Maybe. Maybe you're coolier. Okay. I think that's all I need. Yeah, that's it. That's all you need. You should be able to do this practice in like 5 minutes. Yes, right? Sorry. Yes. I need to see everybody working. I'm still recording. I need to stop it. And you guys are like all crazy for my recording. Right?
We promise we'll do better Monday.
Thank you.
Monday? Yeah, Monday. Oh, no, Monday. Will we come back Monday?